Hello, this is a load in delta configuration supplied by a source of three-phase that can be delta or Y connection. Here you can see the line voltage VL, the line current EL, the phase current IP, and the impedance in all the three phases of the delta connection. Now, let's consider a numerical example of a balanced load delta configuration. You can see here three branches of the delta connection with the letter A, B, C. This delta configuration is supplied by a three-phase voltage 120 volt and 60 Hertz. You can see that the line current IA from the source is equal to the phase current IAB minus ICA. Similarly, IB is equal to IBC minus IAB, and IC is equal to ICA minus IBC. Please notice that the relationship between a line current and two-phase current are of complex numbers. Okay, now we have to calculate XL so we can get the impedance at each branch. XL is equal to 2 pi multiplied by the frequency of the source and multiplied by the Henry or millihenry of that inductance, which gives 10 ohm. So the impedance is equal to 1 plus J10, and its absolute value is equal to 10.05 with an angle of 84.29 degrees. Phase current. Let's say I small p as a phase current. It must be 120 with 0 degree divided by the impedance of the phase, 10.05 with an angle of 84.29. So IP is equal to 11.94 with an angle now minus 84.29 degree. Consider IAB equal to that IP current. So the IBC is equal to 11.94 with an angle of minus 84.29 plus 120 degree. And ICA is equal to 11.94 minus 84 29 degrees plus 240 degrees, which give us the value of IBC equal to 11.94 with an angle of 35.7 degrees, and the current phase ICA is equal to 11.94 with an angle of 155.71 degrees. Converting the phase current in the rectangular form that is equivalent to a polar form, we can finally find that IAB, which is here, is equal to 1.187 minus J1188. IBC equal to 9.696 plus J6967, and ICA is equal to minus 10.882 plus J4991. With this rectangular form of the phase current, we can make the subtraction to find the line current as follows. Let's start with the line current I small c, which is ICA minus IBC or minus IC equal to IBC minus ICA. You make the subtraction of the rectangular form and you will get a minus IC current equal to 2068 with an angle of 5.705. And in the rectangular form, IC is equal to minus 20.573 minus J 2.056 here. In polar form, the line current IC is equal to 20.68 with an angle of 185.7 degrees. Between the line current IC and the phase current ICA, in a phasor diagram, you can see that it is the difference between 185.7 minus 155.7, which gives to an angle of 30 degrees exactly. And you can also see that IC is leading the phase current. Verification with the formula I line equal the square root of DI phase. So I line equal to the square root of 3 multiplied by 11.94, which gives 268 ampere. And the IL, which is the line current, and the phase current IP is 30 degrees. demonstration in a phasor diagram. The current IC makes with the reference axis an angle of 185.7 degrees, and the phase current ICA makes 155.71 degrees with the reference. So the difference of the line current and the phase current is 30 degrees exactly, and you can see that the line current advances or is leading the phase current. Okay, so thank you very much for this example of balanced load delta configuration. My name is Soisit Yang Sao.